Alright, section 7.4. Well, in this section there's really not a lot new other than one small thing. So the difference between this section and the last, this time we're going to be having S for standard deviation instead of the sigma. So in other words, we're only going to know the standard deviation for a small group of people, not the whole population. Consequently, we can't use the z-distribution. We need to use another one. Great news, we get to use a whole new table. Woohoo! So it's called the t-distribution, and that's table A3. Introducing table A3. So the way that this table works is, first of all, notice that it has area for two tails. Well, when we make confidence intervals, we've got a left tail and a right tail. So for this chapter, we're going to be using this two tails. The other thing is, if you're given 95% level of confidence, then the alpha will be 0.05. If you're given 90% as the level of confidence, we would be using this column. The other thing is, on the side, we have what's called degrees of freedom. And here, degrees of freedom is very simply just n minus 1, sample size minus 1. So if you have a sample of size 13, then you would use minus 1, you would use this 12 right here, and then go across to whichever column you need. So as an example, suppose it was a sample size of 43, 95% level of confidence. So here's the table again. So it's going to be 43 minus 1, so we're looking for 43 minus 1 is 42. So we're looking for 42, and the table doesn't have it. Well, this happens in this class that sometimes the table doesn't have exactly what we need. When it doesn't, you just find whatever's closest. Well, there's a choice of 40 or 45. The closest is 40. So I'll be using 40. And because it's 95% level of confidence, then I should be using this 0.05. So go down the middle column, and we're going to be using the 40. So that is right here, 2.021. So there's the critical value. And the formula is basically the same. You just use the t instead of the z. And notice we did 95% in the previous section, and it was a 1.96. So you'll see the t's are close to, but not exactly equal to the z's. There's a little bit of compensation for only knowing the sample standard deviation. So just as before, you take the mean and add the error on one side, subtract the error on the other side. And this is essentially the same formula as the previous section, but this is the t right here. And now let's do a full example. A group of 37 Hartnell College statistics students, they were my students, I asked them how many hours they work. So I found the mean and the standard deviation. Since this 14.18 is the standard deviation for just 37 people, then we need to use the t-distribution. Next, we're going to make a confidence interval for the mean. So write down the data, sample size, mean, and standard deviation. Then calculate degrees of freedom, so that's just 37 minus 1. And then we look over here for a 36. A 36 does show up right here in the table, and I'm using 98%. So that means that in the tails there would be 2%, so it's going to be the second column. So a 36, and there it is. It's 2.434. 2434. That's the critical value. Then we can do the error formula. So put the 2.434 and then the s divided by square root of 37 people. And the error, it's off by 5.674. So in other words, if I say they work an average of 16 hours, I could be off plus or minus 5.674 hours. So then we just do that plus or minus, and we find out that the average is somewhere between 10.3 and 21.7 hours. That's quite a range, and it's because this standard deviation was so big. Hi, thanks for waiting around for after the movie. Next I'm going to show you how to use Graphing Calculator to do that very same problem. Calculator. So first of all, go here to Stat, move over to Tests, and then on my calculator it's going to be the 8th one in the list. It's called T-interval. Hit enter, and this actually we'll be using later in the semester when we have lists of data. For example, if we put all of our data in list 3. Right now we have stats, so turn that on. And now we need that X bar is 16.07, the S 14.18, and N is 37 people. We're using 98% level of confidence, and now calculate. So we see that the numbers are just slightly different in the last decimal place. That's because the calculator uses a more accurate t-value than what's in our chart, but that's just fine. I would say you should be using the calculator anyway, and then we'll all have the same answer. Well, I hope you had as much fun as I did. See you soon.